Speaking of things which are not in the syllabus, one sort of slide that I skipped is that monosaccharides can cyclize, right? We already saw that in a different module. This can actually cyclize to form what is called Phyranose or Phyranose forms. If you're interested in something like this, you can go and make a deep dive into the internet. So this is how that happens. Like this is the, say, a D-glucose is cyclizing. We've seen this typical Phyranose form, this 1, 2, 3, 4, 5, 6 sort of structure, 6-ring structure. But interestingly, you can even have a 5-ring structure. Even though it had 6 carbons, you can have a 5-ring structure where you have 1, 2, 3, 4. It looks a lot like a 5 carbon sugar, but it's not. It's actually 6, because 1, 2, 3, 4, 5, 6. So this is called the Phyranose form. And similarly, our pentoses, which actually have 5 carbon atoms, you would think that, okay, they will always form the Phyranose form, but no, they actually can form what is called a Phyranose form. Okay, and you can have, actually, you can figure out the percentages of how many, like once it cyclizes, what percentages become an alpha and beta, and what percentages of those actually form Phyranose and Phyranose. Okay, something interesting. And another thing that I skipped, which is not in the syllabus but it's quite interesting, is over here with the glycoconjugates. So I just talked about glycoconjugates, but I didn't get into the details of why they're important. So one of those things is that it has a lot of structural features and properties. And like we looked at this, right? We looked at this cell membrane thing, and we looked at how you will have a protein, and then there's some sort of carbohydrates or oligosaccharides linked to that. Okay, and another interesting property which we did not look into is blood IBU antigens. We all know that we have this three sort of type A blood, type B blood, type O blood, and type AB blood. But the whole how you can actually figure it out, or what is the thing that makes them different, is related to these glycoconjugates. Again, since it's not in the syllabus, you're welcome to go ahead and Google it up at your convenience, but it's something pretty interesting. And so that's about it. So lots of hidden slides which I have not covered in the syllabus and have not included in the syllabus. So basically we think of structures as basically we think of the roles of polysaccharide as structural, starch, or energy storage, glycogen. Okay, so sorry, cellulose as structural and starch and glycogen. This is energy storage. Okay, other structural molecules like chitin, dextran, and so on and so forth. But there are a lot of other informational or sort of sophisticated things that they do, which again is not in the syllabus. For example, they play a role in protein-protein interaction. They have they can actually activate certain molecules in your blood, and they can form as receptors for ligands and cell surface. They can cause they can help attract certain like charged molecules and stuff. Okay, so they have a lot of other informational roles in the body and in the cells, which we are not covering in our syllabus. But again, if you are interested, you can Google it up. That's about it.